So the last time you would have drawn some isomers, and now we're going to name these branch chain alkanes that you would have drawn. Okay, so our first step is we need to find the longest chain. So let us look. So this is our example right here, and we are going to find the longest chain. So you could either have this chain right here with two little carbon atoms, or we could have this right here, this very long chain, okay, that has 8 carbon atoms, okay? So most definitely, this would be the longest chain, right? Very good. So this right here is our longest chain. The next step, the next thing we need to do is we need to number the carbon in the longest chain so that each substituent gets the longest number. The substituent is anything that is attached to the longest chain, also known as the parent chain. So right now we have this group right here being attached to our parent chain. So now we need to give that group a number, and we're going to do that by numbering our parent chain. So this carbon gets number 1, this carbon gets 2, 3, 4, 5, 6, 7, and 8. Okay, so we could either count it from left to right, which gives us carbon 1 through 8, okay, and this carbon, our substituent, would be on carbon number 4, or we could count from right to left. And in that case, we would get 1, 2, 3, 4, 5. This would be on carbon number 5 if we would count it from right to left. Okay, so we're going to count from left to right because left to right gives us this substituent on the smallest number, which is the 4. Okay, okay, so our substituent has a number. Now we need to give the substituent a name. Okay, so that's our second step. That brings us to our next step, which is to identify the substituent. Okay, we identify the substituent, all right, by giving it a number and a name. So we've given it a number already, which is 4. Now we need to give it a name. So the name we're going to give it is, we're going to look over here in order for us to find a name. So this has 1 carbon atom, all right, a CH3 group. If we look over here, CH3 gives us methyl. So that's the name of our substituent. So our substituent has a number and it has a name. Good. Next thing we're going to do is we're going to use dashes between the numbers and the names. So here we have the number 4 for our methyl. Okay, and then we're going to have it followed by a dash. All right, the name methyl, and then we're going to put the name of the parent chain. The parent chain is like the last name. It always goes at the end. So a carbon atom is going to give us octane. So let's go again. So 4, so we have to identify a substituent. Okay, so our substituent goes at the beginning and our last name goes at the end. So our substituent, we give it a number and a name. We give it a 4. All right, and we said that it was a methyl group. Okay, but you can't just write 4 methyl. You have to write a dash in between the number to separate the number from the name. So you have a 4 dash, methyl, the name of our substituent, and then the last name. Okay, which is our octane because we have the longest parent chain has 8 carbon atoms. That is it. Okay, that is it. Okay. We also have a step number 6, and this is used in the event that you have more than one of the same substituent. Okay, so we only have one substituent here, so we don't need commas. But if you had more than one of this group, then you would have used the commas. But we did not have that here. Okay, so now we have another branch chain alkane to name. So the first thing we need to do is we need to find our longest chain. So this chain right there has 1, 2, 3 carbon atoms, and this only has 1. So which one is the longest? This one at the top. Correct. Very good. Okay, so the next step is telling us that we need to number the carbon in the longest chain so that our substituent, which is this group right here, gets the lowest number. So we could start counting from left to right, or we could count from right to left. So counting from left to right gives us this carbon being 1, this carbon being 2, which is what this is attached to. So this gets a 2 if we start counting from the left, but if we come from the right, we get this is 1, and then this is also 2. Okay, we come from the right. So that's telling us that this carbon right here is, okay, it's carbon number 2, and that is what our substituent is attached to. So that's its number. Okay, the next thing we need to do is we need to identify the substituent. What is the substituent going to be called? It's just still again one carbon atom. So one carbon atom, we look at our table. If we look at our table, one carbon atom gets the name methyl. Okay, so that's his name. All right, the next thing we have, okay, so that's his name, methyl. All right, now the next thing we do is we're going to recap again the name and the number of our substituent. All right, and then we're ready to write it all together. So we have the substituent, we said that is, we give it a number, which is number 2, and then we also give it a name, which is methyl. Okay, so now the next thing is we need to remember to put the dashes in between the numbers and the words. All right, and then we just attach our long chain, which is our alkane, aka our parent chain, and that is it. So let's put it all together. And of course, commas are used for more than one substituent. So let's put it all together. So here we are going to call this 2, because the 2 is for this. Remember our methyl, we gave him the number 2 and we gave him a name, methyl, because there was only one carbon atom. So, and then we have a dash because we always have to use dashes between numbers and names. So you have a 2 dash, your methyl, and then of course your last name, which is your parent chain, which is only 1, 2, 3 carbon atoms. So we call it propane, right? And that is it. That's it.